One of the more common type of question we have with surds, we end up is rationalising the denominator. Does anyone know why we rationalise the denominator? I mean, you've been taught to do it. You've done I don't know how many different questions on it, but do you know why you do it? It's to do with comparison. Like if you want to know which one's bigger, if I said to you over here I've got 1 on root 2, and over here I've got 2 times the square root of 2, that's probably a bad example to pick, but which one's bigger? It's really hard to compare because one's got the surd on the bottom, one's got the surd at the top. It is just easier to compare when we say multiples of the surd. And so that's why we always put the surd on the top, because then we can compare. We can say, oh, well, it's 3/4 root 2, or so on, and you can compare. The same thing happens with complex numbers in extension 2. We'll see that as well. In that case, we don't call it rationalise the denominator, we call it realise the denominator, but it's still the same idea. Well, let's get back to our simple little one here. 4 on the square root of 2. So how do we do it? Well, we want to make it a rational number, so we multiply by the surd. Root 2 on root 2 is, of course, equal to 1, so we haven't changed the question. We have 4 root 2 on 2, which is 2 root 2. But then we had one, oh no, sorry, I'm jumping ahead. Oh yes, I use this example just to illustrate you don't have to multiply by 2 root 5, just the surd part's fine, because that's what you're trying to fix up. So just root 5 on root 5, 3 root 5 on 10. Now if you did multiply by 2 root 5 on 2 root 5, it's not wrong, it just means you'll end up with some cancelling to do down the track. Okay. So here we have the binomial on the bottom. This is where we multiply by the conjugates, because we want to try and leave a rational number on the bottom, and the difference of 2 squares will create a rational number. So we get 3 root 2 plus 3 on 2 minus 1. Well, 2 minus 1 is just 1. So 3 root 2 plus 3. This sort of question you see a lot, where the top is the conjugate of the bottom anyway, and so you end up with a perfect square on top and the difference of 2 squares on the bottom. Look, it's just a coincidence that the denominator here turns out to be 1 again. Little tip, it's not always 1, okay? 4 minus 3 in this case, which is 1, 7 plus 4 root 3. Okay.